Assalamu alaikum warahmatullahi wabarakatuh. We are welcome to physics class today, and we want to continue from where we stopped in the class. In the class, we have discussed current electricity. We've defined current electricity. We've looked at the devices that can be used to measure current electricity, like ammeter. And we have various types of ammeter. We have milliammeter, microammeter, and galvanometer. We have equally looked at circuits, where we define circuit as the part provided for the flow of electric current. And we have three types of circuit. We have open circuit, we have closed circuit, we have short circuit, and all these were extensively discussed. Now, in this our discussion, we are going to be looking at more about current electricity, and in this class, in this video, we want to talk about Ohm's law. Right, Ohm's law is what we are going to be talking about. So at the end of the lesson, we are going to be able to define or state Ohm's law and write ohmic equations. 2, we are going to be able to solve problems with ohmic equation. 3, we are going to state limitations of Ohm's law, and finally define resistors, state types of resistors with their examples. Going into the discussion fully, what is Ohm's law? Ohm's law states that provided that temperature remains constant, the electric current that flows through a metallic conductor is directly proportional to the potential difference applied across its end. So if we look at this definition, there are three key things there. 1, temperature must remain constant. 2, the current that flows through a metallic conductor is directly proportional to the potential difference across the ends of the conductor. And mathematically, we have current to be directly proportional to potential difference, or we can say potential difference is directly proportional to current. We have symbolically V to be equal to IR. So what this equation means is that if the current is increasing, the voltage, if the voltage is increased, the current will increase, vice versa, despite that the resistance remains constant. All right. Now we have ohmic equations. From V equals IR, we can write equation for I and R. If I is made subject, I can have I to be equals to V over R, and writing equation for R can be equals to V over I. So all these three are called ohmic equations, and they can be used in solving problems. Now my I stands for current, V stands for potential difference in volts, the current is measured in ampere, the R stands for resistance of conducting wire, or can refer to it as proportionality constant. Now the unit for resistance is ohm. Now let's see how we can apply these equations to solving problems. That is the second agenda. 1, the voltmeter connected across a 4 ohm resistor reads 12 volts. Calculate the current that flows through the resistor. Okay, let's look at what we are given in the question. In the question, we are given R to be 4 ohm, volt to be 12 volts. We are looking for current I. The formula to be used is equals to I equals V over R, and V is 12, R is 4. 12 over 4 will give me 3 amperes, and that is the answer that we are given in the question. Right. Number 2, you have a PD of 240 volts applied across the heating coil of an electric kettle, drives a current of 8 ampere through the coil. Calculate A, the resistance of the coil, B, new current through the coil if the PD applied is changed. So let's look at the first one. We are given the first voltage to be 240 volt, and the first current to be 8 ampere. We are looking for the resistance. So using R equals to V over I, we have 240 over 8, that will give us 30 amperes. Now in the second question, what if the voltage, the PD is changed from 240 volts to 220 volts? What is going to be the current? Now we should be able to guess what the current should be. The current is going to drop since there is voltage drop. If the voltage drops, the current drops, and if the voltage should be increased, the current will increase. So what we have here is 8 ampere when we're having 240. By the time the voltage is dropped to 220, our new current should be reduced, should be lower than 8 ampere, and this is what we have at 7.33 ampere. So let's find out if this answer will be so. Right, using new current is I2, we don't know that. Our new voltage given to us is 220 volts. So using the formula I2, which is new current, is V2, new voltage over resistance R is constant. That will be 220 over 30, and that will be 7.33 ampere. You can then see that this current is lower than this current, so it shows that the voltage has been dropped to 220 from 240. So current equally drops from 8 ampere to 7.33 amperes. Alright, going to discussing limitation of Ohm's law. The following are limitations of Ohm's law. There are some materials that don't obey Ohm's law. And 1. Ohm's law holds for metallic conductors and other certain materials. So it means that for non-metallic conductors and for non-insulators, they don't obey Ohm's law. 2. There is need for temperature and other physical conditions to remain constant. Ohm's law does not work if temperature is not constant. And 3. Ohm's law does not apply to conductors like radio valves, transistors, semiconductors, neon gas, and acid. These are limitations of Ohm's law. And on the final note, we want to look at resistors. What are resistors? Resistors are electronic devices that offer opposition to the flow of current in a circuit. Any material that opposes the flow of current in a circuit is called resistor. Is known as resistor. The inability of resistor to oppose flow of current is called resistance. Alright, and the resistor of wire is measured in ohms. We talked about that earlier. Now here we have a picture of resistor, but we have so many types of resistor and pictures. We're just picking one, and we can see the color on this resistor has its application that will be discussed later. Now we have symbols of resistors. We have this to be European symbol. This one is USA symbol. Two can be used in electric circuit diagrams. Alright, we are looking at types of resistors. We have standard resistor, and the standard resistor is a resistor whose value of resistance is known, or that has a fixed value of resistance. Okay, we have e.g. 1 ohm, 2 ohm, 3 ohm resistor. All these are standard resistor because their values are known. And this picture is one picture from so many examples, for many designs of, let's say, standard resistors. And this one can equally come in different values. Alright, we have them in physics labs. Okay, we equally have variable resistors. This is a resistor whose resistance can be changed, whose resistance can be varied in circuits. We have rheostats, but one prominent one, we have different pictures of rheostats here. This is another variable resistor. Now the prominent one that is mostly used in WAEC and NECO physics practicals is the resistance box. Okay, we have picture of resistance box here. This box has various or several standard resistors. This plot you see here, they are standard resistors, and it is used to provide standard variable resistance into a circuit. So the key, that the plug that is removed here, indicates the resistance value that is in the circuit. Okay, so if you need the resistance of the circuit to be changed or varied, you need this box. Is the most suitable to provide such variable resistances in a circuit. Alright, we have been able to take care of what I have for you today. We've been able to state Ohm's law and write ohmic equation. We've been equally we have equally applied ohmic equation in solving problems with stated limitations of Ohm's law, and then the fire resistance, resistance, look at types and their examples. If you haven't subscribed to my YouTube channel, please do so that you can get more videos as they are uploaded. Thank you for your time.